everyone. So in this tutorial we'll be understanding about OpenLane. It's going to be a short introduction to OpenLane. Wait a second. So in the agenda, what's the agenda of this presentation? The first we'll be starting off with understanding OpenLane, what is OpenLane and what's the purpose of OpenLane. Then we'll be looking to RTL design and the foundational data circuits, then the OpenLane load bridging the gap from RTL to GDSII, and the key feature and the benefits of OpenLane, practical application and impact. Then also we'll be looking to the future of open source EDA tools. First of all, we start off what is OpenLane. So most of you may be wondering what is OpenLane. Like you guys may not know what is OpenLane. So we'll be discussing about OpenLane. OpenLane is an automated open source RTL to GDSII flow for design data ASIC. It leverages various open source electronic design automation, which also stands for EDA tools to perform the complex steps required to transform a high-level design description into a physical chip layout ready for fabrication. Now, what's the understanding of RTL design? RTL stands for Register Transfer Level Design and Abstraction. In the design flow of the integrated circuit is described the data circuits in terms of data flow between hardware registers and the logical operation performed on the signals. After that is the high-level abstraction, focuses on functionality or physical implementation. After that comes the hardware description language. Language is HTL, Verilog, or VHDL. So before we move on, let me clear that Verilog or VHDL is not a programming language, it's an hardware description language. I hope that's clear. So use Verilogs or VHDL to describe the circuit's behavior. Then is the foundation for synthesis, the input for automated tools that translate designs into gate-level netlist. Then we're discussing about what's the OpenLane call function. So synthesis transform RTL into a gate-level netlist. Then comes the floor planning, defines chip areas and I/O pins placement. Then comes the placement, which aligns the slanted cells within the floor planning. Now the routing connects cells with metal wires. And then the DRC LVS will define design tools, verify design rules and netlist integrity. Now, the main important point, what is benefit of using OpenLane? What's the point of using OpenLane? So, the first comes is the accessibility. So, it lowers the entry barrier for chip design with open source tools and compressive documents. It's the efficiency automated for reduces design time and improves productivity for complex projects, and also the community support. So it also had the active community provide support, so and bug fixes and continuous improvement in the thing. So now it also comes with the cost effective. It's cost effective, which means it eliminates the expensive chemical EDA tools license, which also means making a chip is a lot more affordable. Now, what's the application and impacts? So, OpenLane is a curriculum for rapid prototyping, academic research, and developing custom silicon for specialized application, fostering a new era of open source hardware, which means a custom ASIC development for load in AI, artificial intelligence, education tool for VLSI design courses, research platform for new EDA algorithms, enabling smart teams and startups to develop silicon. And that's it for this video. And yeah, if you have any question or any concerns, you can ask in the comment section.